Okay? Let's say one morning, someone wakes up and says, forget skyscrapers, forget Burj Khalifa. I want a building so tall it has 1 billion floors, 1 billion stories, not thousands, not million, billion. That's not a building anymore. That's basically trying to poke the universe with an elevator shaft. So let's try to imagine this. The tallest building right now is the Burj Khalifa in Dubai, about 160 stories, just under 1 kilometer tall. If we wanted a 1 billion-story building, and each floor was 3 meters high, like a normal apartment, that means 3 billion meters. In other words, 3 million kilometers tall. For comparison, the moon is only 384,000 kilometers away. Your building would be nearly 8 times taller than the distance to the moon. Congratulations! You've officially built a tower that sticks out of Earth, blasts through the atmosphere, past the moon, and just keeps going. Now, the first problem is gravity. Skyscrapers work because steel and concrete can hold up the weight of what's above. But if you keep stacking, eventually the bottom floors get crushed. Even a few dozen kilometers is impossible with normal materials. 1 billion stories. The base would collapse under pressure like a soda can under a mountain of bowling balls. In fact, it would be like trying to balance Mount Everest on top of itself again and again, until you had 1 million Everests. But let's say somehow you used a magical, indestructible material. Your tower punches straight out of the atmosphere. At 100 kilometers, you're already in space. Keep climbing, and your building passes satellites, then the orbit of the moon, then Mars's orbit, and maybe even all the way out toward Jupiter. Somewhere around floor 700 million, the view out your window is Jupiter's great red spot. Sounds cool, but what about elevators? The fastest ones today move at about 60 kilometers an hour. If you wanted to ride from the ground to the halfway point, it would take nearly 6 years. One way, you'd need rest stops, food courts, and maybe even generations of elevator babies born along the ride. Imagine explaining that to your landlord. Even if you had infinite patience, Earth itself would fight back. The planet spins at about 1,600 kilometers per hour at the equator near the top of your building, millions of kilometers away. That spin would fling the tower sideways. The entire thing would either snap off or start whipping around space like a giant flail. Either way, not great for the people trying to sleep on floor 7. And here's the strangest twist. At a certain point, your building stops pointing up because up changes as you leave Earth. Gravity pulls toward the center of the nearest big object. Once your tower is far enough, the moon might tug at it. Go farther, and maybe Jupiter pulls harder. Eventually, the top of your building isn't even connected to Earth in the way you'd expect. It's stretched toward another planet, slowly warping into a weird, impossible space tether. It's less like a skyscraper and more like you're trying to stitch the solar system together with an elevator shaft. So could you actually build it? No chance. The materials would fail, the elevators would be useless, Earth's rotation would rip it apart, and gravity would constantly shift the rules. But thinking about it shows us why skyscrapers are limited not by imagination, but by physics. And physics doesn't negotiate. If you really want a structure that reaches space, engineers dream about a space elevator. That's a cable stretching from Earth into orbit, held up by centrifugal force. Way more practical than stacking 1 billion apartments on top of each other. Still wildly difficult, but at least not totally insane. So, next time someone brags about living on the 40th floor, just remind them, at least they don't have to take a 6-year elevator ride just to borrow sugar from their neighbor. If you enjoyed this little thought experiment, hit like, drop a comment with your own what-if idea, and subscribe for more science adventures. After all, who needs stairs when you've got imagination?